Hey guys, today we're going to look at our second biomechanical principle on Newton's law of motion. By the end of the lesson, you should be able to do the following. Name all the three laws and be able to apply them to basketball. Alright, what is Newton's laws? Well, essentially this guy, Sir Isaac Newton, came up with three laws to do with motion, and they're pretty simple to understand. Alright, so our first law is called law of inertia. Inertia is a resistance of an object to a change in its state of motion or rest. So as you can see below, we have two objects that will not move unless something acts upon it. So as you can see in the person holding the basketball, that ball will not move until force is applied onto that particular object. And the same with a tennis ball. That tennis ball will not move unless a force is applied upon it. However, in the same way, this ball will continue moving until something acts upon it. Right, so inertia is a resistance of an object to change. In the first case, right, this ball here will continue going until a force acts upon it, right? So it'll continue going until a force acts upon it. Some of these forces that could act upon it could be a collision with the ball, collision with the wall, sorry. Right, could have air resistance acting upon it to slow it down, and it could have gravity pulling the ball down. Alright, and another example could be that the ball will stay here until I apply a force to this particular object. Alright. Right, law 2 is law of acceleration. And essentially what this law is saying is that acceleration of an object is proportional to the force that acts upon it. So we need to remember this simple formula, okay, which means force equals mass times acceleration. Right, so force means something we place upon a particular object, and motion is a result of that particular force. Law of acceleration in practice says that if we use the same force, okay, so if we use the same force on a small object, there is obviously going to be a large acceleration. Okay, so a large acceleration. However, if I apply the same force on a large mass, for example here, which is a car, it's going to equal a small acceleration. So the acceleration is directly proportional to the force we place upon it. So if we want to have the same acceleration on a big object as a small one, obviously we're going to have to apply more force to that particular object. Nice and simple rule. How fast something goes is proportional to the force we put on it. Right, if we were to take, let's change the colour here. Okay, if I was to take, right, we'll go over here. If I was to take a tennis ball and a medicine ball, alright, and we compare that, and we wanted to throw the ball at the same height, obviously we're going to have to put more force behind the medicine ball because the mass is larger, right, for it to get higher into the air compared to the tennis ball. Alright, and the third law is called law of action-reaction, which means for every action there is an equal and opposite reaction. Alright, and we have a few pictures here, and let's have a look. Alright, so with my swimmer here who's jumping off the diving board, right, the action is the swimmer pushing his feet onto the board, and the reaction is pushing him up off the board into the air. Okay, as you can see there. Our next one with the skateboarder, the action is where he's pushing his foot one way, and the reaction is that the skateboard slips out from under him on the opposite side. Alright, next one here. If this was a wall here, so if we were to put, if this is a wall here, right, the action is he's pushing against that wall, and the reaction force is a wall pushing back against him. Alright, the baseballer, the action is a baseball hitting the ball, and the reaction is a ball flying through the air. Alright, and with the volleyball dig, okay, the action is a person hitting the ball, and the reaction is a ball flying off the female's arms. Alright, so we all know, okay, if we were to go back, sorry. So, what's happened here? Okay, we all know law of inertia. So we've kind of talked about three laws. Okay, law number one, law of inertia. We said that inertia is the resistance of an object to a change, whether it is in a state of motion or at rest. Right, then we've also talked about law 2, which is law of acceleration. Basic means the acceleration of the object is directly proportional to the force we place behind it. And lastly, law of action and reaction. For every action, there is an equal and opposite reaction. Alright, now we're just gonna, where's my lazy, sorry guys. Now we're gonna look at this in a basketball application and how all three laws are applied. Okay, so I've taken an example of a jump shot for my basketball example. Alright, so as you can see in the picture here, and I'll just change on it, it's red. Okay, as you can see here, the ball is stationary, so this is applied to law 1, which is law of inertia. So once again, the object will remain motionless or at rest unless I apply force onto it, and the force is coming when I extend up. My force is coming from my triceps brachii to place force onto the particular object for it to move. Alright, and how can we apply law 2, which is law of acceleration? Alright, that basically means acceleration of an object is directionally proportional to the force that we can place upon it. So basically I need to consider force equals mass times acceleration. This means the greater the force I apply onto the ball, the further it will go. So as you can see, basketball has a larger mass. right, and it's bigger. So I'll have to apply more force onto that particular ball for me in order for the basketball to travel to the hoop. Alright, and for my third law, okay, when I jump off the ground, okay, when my feet generally on the ground, this is my action, right? My feet pushing into the ground, and my reaction is the floor pushing me up into the air. Alright, hope you guys have found this useful, and if you've got any questions, don't hesitate to ask me in class. Thank you.